Hello, I welcome you all. The 10 kg block is held at rest on the smooth inclined plane by the stop block at A. If the 10-gram bullet is traveling at 300 meters per second when it becomes embedded in the 10 kg block, determine the distance the block will slide up along the plane before momentarily stopping. This problem is coming from the Engineering Mechanics and Dynamics, our 14th edition by RC Hibbeler. Right, so what are we supposed to do here? Right, so what are we supposed to do here? We are going to use the principle of conservation of, the conservation of momentum, as well as conservation of energy. But mind you, here we are on the inclined plane. Again, there are a lot of ways to solve this particular problem. For me, I'm going to choose this as my axis. Okay, this will be my reference axis, right? Let me draw this properly. Okay, something like that. So we'll call this y, this one x. Right, so it means we'll have a component in this direction for this. This is what we are interested in. We'll have a component in this direction and another one in this direction. Okay, in fact, instead of doing it like that, I'm going to take this one down. Okay, like so. Right, there we go. So this is our y. Alright, so what do we have? So this becomes, of course, this angle here. This angle here is 30 degrees. Okay, this is 30 degrees, and this therefore is 300 cos 30. This one is 300 sin 30. Right, so our interest is this one. Right, so if this becomes a reference, this is the starting point, this point here, sorry, this point here. Alright, so the idea is, alright, something like that. Alright, there we go. Okay, so let's start working. So now we're going to use the principle of conservation. Mi vi in state 1 is equal to summation mi vi in state 2. Right, so let's call this b, then we call this more b. Okay, so this becomes, so we have mb vb1 plus mb vb1, then this is equal to mb like so v2. Of course, this one is 0. What do we have? So we are interested in mb. This is how many grams? 0.01. okay, kg times VB, again we're interested in the one along the x-axis. Okay, equals to we are adding 0.01 plus 10 v2 along, this is along the x-axis. Okay, therefore our v2x in this particular case will be equal to 0.01 by 300 by cos 30 divided by 10.01, and this gives us a 0.2595 meters per second, right? Let me try this once more again. Okay, times 300 times cos 30 divided by 10.01, this will get 2595. Alright, so we have this one. What we need to do now is to calculate the height. Once we have the height, then we can calculate this one here, this distance here. Okay, then we calculate this distance here, right? You see this distance here I'm calling d. Okay, so I'm going to use using the conservation of mechanical energy. This just becomes T1 plus V1 equal to T2 plus V2. T itself is just equal to half m V squared, and V is just equal to Vg plus Ve. So what do we have? Right, the idea is to find the distance that the block will cover along the plane before momentarily stopping. So in fact, instead of this, we're going to call it 2. Okay, state 2, because we are in we'll call it state 2, then this one 3. Okay, so this one is 1, then we have 2, then we have 3 somewhere. Okay, are we there? All right, we're there. Great. So what do we have? In state 2, both the bullet plus these are embedded. They are embedded, and we have V2. Okay, this is half like that squared, then plus V2 itself. So this is just all 0. Okay, so this is just equal to then we do have T3 plus VE, VG is there. I've acquired some, so this just becomes WB plus W this times H3, then plus VG VE. Okay, let me move this a bit. I move it just a bit like so. Okay, there we go. Right, so we know that this is 0, this is 0, this is 0, and this is 0, right? So we have now half our MB is 0.01 plus 10, and then we have our V2. Our V2 is just equal to 0.2595 squared, and this is equal to WB. So this is just 10.01 by 9.81 H3. Therefore our H3, which is this one here, will just be equal to that's 10.01 by 0.5 by 0.25 95 squared divided by 1.01 9.81. Okay, so this height is very small. It's 3.4322 times 10 to the power -3. Okay, let me check it once more. 10.01 by 0.5 by 0.25 15 squared divided by 10.01 by 9.81. Okay, 3.4322 times 10 to the power. Alright, so finding D, we're just going to use hypotenuse. I mean this is 30. Okay, so we know that sine, so let's now find D. So we know that sine 30 degrees is equal to H3 divided by D, and therefore D is just equal to H3 divided by sine 30. Okay, and this is just equal to 3.4322 by 10 to the power -3 divided by sine 30. D is just equal to 3.4322 times 10 to the power -3 divided by sine 30. This is 6.8644, okay, times 10 to the power -3 meters, and therefore D, this is just going to be equal to 6.8644 millimeters. Okay, can we just write it to 2 decimal places like so. Right, so this is the distance that the block is going to slide up along the plane before it momentarily comes to a stop. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.